Welcome to today's explainer. We're going to dive into what can really only be described as the pivot of the century. We are looking at a brand that pretty much every single PC gamer knows intimately. But, here's the truly fascinating part. While we were all staring at our monitors, totally mesmerized by these cutting-edge graphics, this company quietly, almost secretly really, transformed itself into the absolute indispensable engine of the modern AI revolution. Think about it. For years, if you heard the name Nvidia, your mind probably went straight to one thing, right? Gaming. You pictured hyper-realistic pixels, massive on-screen explosions, and these sprawling, immersive virtual worlds. But contrast that highly visible outcome, the video games we all see and play every day, with the incredibly complex, hidden, and super dense neural networks that run underneath our modern technology. Nvidia wasn't just rendering cool graphics for gamers. They were actually mastering an entirely new way of processing data. They were laying the invisible groundwork for a technological earthquake that would fundamentally reshape the global economy. So that brings us to the ultimate question we're unpacking today. How exactly did a PC gaming brand become the undisputed backbone of the global AI economy? Really think about that huge leap for a second. How did a company building graphics cards for your weekend gaming rig end up building the trillion-dollar infrastructure for the world's most advanced artificial intelligence? It is an absolute masterclass in strategy, patience, and foresight. So let's unpack this journey step by step. Let's kick things off with the parallel processing advantage and unlocking this massive hardware secret. To really grasp how this huge pivot happened, we have to understand the mind-boggling mathematical demands of artificial intelligence and how it completely differs from traditional computing. Picture a traditional CPU, the central processing unit in most computers, as a high-speed delivery van. It is incredibly blazing fast for sure, but it has a major limitation. It can really only handle one delivery or one task at a time. It rushes back and forth sequentially. Now, compare that to a GPU, the graphics processing unit. The GPU is a massive freight train. It might not race down a tight alleyway at 200 miles per hour like that delivery van, but it carries thousands of pieces of cargo simultaneously. It performs thousands of smaller mathematical tasks all at the exact same time. And the crazy thing is, while the rest of the tech world was obsessed with trying to build a slightly faster delivery van, Nvidia was quietly, relentlessly building a massive train. So what does a massive freight train of processors actually have to do with artificial intelligence? Well, it turns out this was a brilliant, almost poetic accident of hardware design. The exact same parallel processing technology required to accurately render, say, the wind blowing through thousands of individual blades of grass in a video game, calculating light, shadow, and physics all at once, is perfectly suited for training an artificial neural network. Neural networks don't actually need one super-fast calculation to think. They need millions of tiny interconnected math problems solved all at the exact same instant. Nvidia's gaming hardware was already doing exactly what AI would eventually need to function. It was a perfect, totally unforeseen match. But hardware is just one piece of the puzzle. That brings us to CUDA, the software moat, and a massive billion-dollar gamble. Having the right hardware was really only half the battle. Nvidia's greatest genius wasn't actually their physical microchips. It was a massive software bet called CUDA. Before CUDA, a GPU was essentially a locked black box. It was really only useful for rendering graphics. But launched way back in 2006, CUDA is basically a software platform that acts as a universal translator. It completely unlocked the GPU, giving developers the programming tools to push these chips way beyond gaming and into the realm of complex, general-purpose mathematical computing. It literally opened the floodgates for scientists and researchers to use graphics cards to solve some of the world's absolute hardest problems. Now, the timeline of this gamble is where the narrative tension truly peaks. In 2006, the platform launches. And for an entire decade into the 2010s, Nvidia poured billions of dollars into developing, refining, and supporting CUDA. The catch? They saw almost zero revenue from it during that entire time. Imagine explaining to Wall Street that you were spending billions on a software platform that nobody's really paying for yet. It was a staggering financial risk. But they were meticulously building an impenetrable software moat. By the time the AI boom finally arrived, every major researcher, university, and developer in the world was already trained on and heavily reliant on CUDA. If you wanted to build AI, you kinda had to use Nvidia. It created a massive vendor lock-in, a moat that tech giants like Intel and AMD are still desperately trying to cross today. Okay, so what happens next? We see the massive data center shift and the building of the AI factory.
Around 2016, this totally dominant combination of hardware and software triggered a fundamental structural shift in their business. Nvidia evolved into an AI factory ecosystem. They realized, hey, we need to stop just selling individual graphics cards to gamers and start selling entire integrated AI supercomputers to tech titans like Google, Meta, and Microsoft. First, they introduced the legendary A100 and H100 chips, which very quickly became the most sought-after commodities on Earth. But, a pile of chips isn't a supercomputer. Second, they provided the insanely advanced networking required to string tens of thousands of these chips together so they could talk to each other without bottlenecks. And finally, they provided the integrated software to make this massive factory hum perfectly in unison.
And this brings us to a foundational realization about modern technology. Nvidia didn't just provide a component anymore. They became a comprehensive system company. To use an analogy, they were no longer just selling the high-performance engine. They were selling the entire race car, the racetrack, and the highly trained pit crew, the whole shebang. They evolved into the ultimate turnkey infrastructure provider. When a massive corporation wanted to build a modern data center, they didn't buy parts. They literally just bought Nvidia. Which perfectly sets the stage for fueling generative AI in what is basically the modern gold rush.
Fast forward a bit to the launch of ChatGPT. You all remember it. The world changed practically overnight. Suddenly, generative AI went from being this abstract research paper to a daily consumer reality. Generating text, images, and code required unprecedented, almost unfathomable amounts of compute power. ChatGPT was the spark, but Nvidia had been quietly filling the room with gasoline for 10 years. When the generative AI gold rush truly began, Nvidia was the only company standing there fully ready to supply the heavy machinery. And because of that decade-long software gamble and their massive data center ecosystems, they captured an astonishing 80% of the entire AI chip market. The competition simply wasn't prepared for the sheer, sudden scale of the demand.
But Nvidia isn't stopping at text-generating chatbots. No way. Their next evolutionary step goes beyond traditional silicon chips entirely into what they call the Omniverse. This is a staggering platform designed for industrial AI and the creation of digital twins. Imagine being able to mathematically simulate an entire physical car factory, a complex global supply chain, or a massive city's power grid down to the exact millimeter. You can test it, break it, and completely optimize it in virtual reality before pouring a single ounce of concrete in the real world. They aren't just powering artificial intelligence anymore, they are aiming to simulate the entire physical world. So, where does this all lead? To the engine of tomorrow and anticipating the world's needs. Ultimately, Nvidia's true overarching strategy wasn't just about making a slightly better microchip. It was about seeing exactly where the world was going and painstakingly building the tools humanity would eventually need, a full decade before AI became a household word. They built the massive computing train, they laid down the sprawling software tracks with CUDA, and they constructed the data center stations, all while the rest of the tech world was looking the other way. So I'm going to leave you with this heavy, provocative question. Has the AI powerhouse already won the race? Or is there a competitor out there who can actually bridge this massive decade-in-the-making moat? Take a moment to really think about that scale of strategic foresight. Thanks so much for joining me on this explainer, and keep learning.